What's up, guys? Welcome to another PalaView education video. Today, we are going to be breaking down the different blockchain layers, right? A lot of you are asking me, Asani, what are the different, what is the difference between layer one, layer two? What is a layer two? So I'm going to just break down the different layers of blockchains because actually, there's more than just layer ones and layer twos. So, first, we got to start off with layer one. Of course. Layer one is really just a blockchain, okay? And it's constituted of these five components, okay? So there's the application and presentation layer, which includes smart contracts, chain code, blah, blah, blah. And then there's, of course, the consensus layer, which is basically how consensus is achieved on the blockchain, because if you are creating a distributed system, then you have a system of a bunch of different hardwares, right, at the bottom, virtual machines, things like that, you know, miners, right? All these different rigs have to communicate with one another, and so how they reach consensus with one another is what that layer does. There's a network layer and a data layer because obviously you got to ledgerize, you have to hold a ledger and hold records of the transactions that occur on the system or the blockchain. If not, then you don't really have a blockchain, do you? So, building off of that foundation, let's talk about the four different blockchain layers. You got 0, 1, 2, and 3. So layer zero, right, is a category of blockchains that gives the development team tools to build other blockchain networks on top of it. In other words, layer zero blockchains can become a platform for any number of other blockchains. It is usually the technology and software, typically open source, that other development teams can use. The function is to provide the software and technology infrastructure so that all the blockchains on it can work simultaneously, right? And can actually interact with each other and work together. So, in this context, layer zero provides the network layer and infrastructure for the blockchains that are built on top of it, which can include a layer one. So let's use Avalanche as an example because we love Avalanche here at PalaView, if you haven't noticed. So in this example, a layer zero is Avalanche, okay? And a Avalanche's layer one is actually its C chain, okay, which is essentially an Ethereum virtual machine, okay? It uses the same Solidity smart contract code as Ethereum does, but it leverages the technology and consensus mechanisms of the Avalanche blockchain, which is the layer zero blockchain. So Avalanche, just to talk about Avalanche a little bit more, has three different chains. It has the contract chain, the C chain, which is the one I just talked about, the exchange chain, the X chain, and the P chain. So we'll talk about those a little bit more later. A layer one is like we were talking about before. It's a decentralized platform that has all the five blockchain layers that I was showing earlier. The function of layer one is to facilitate various types of transactions and to ensure that the network is secure. The majority of layer ones now are smart contract driven, and they allow other applications and protocols to exist on top of them. Okay, it's pretty much that simple. And that's like, they're the ones that are hosting that DApp ecosystem. That dApps is like a decentralized application. It was more of a common term back in like 2016, 2017. But dApps include things like SushiSwap, Uniswap, all the stuff we were kind of talking about yesterday. And examples of blockchains in layer one world is Bitcoin, Ethereum, Solana. I see Cosmos is here, and maybe it shouldn't be, even though I don't really consider Cosmos to be a layer zero, even though it is shown here, and we'll talk about that more later also. So layer two blockchain is a blockchain that solves problems that the layer one can't, okay? So this technology exists on the top of a layer one to address what, typically scalability issues. So Ethereum has Polygon, right, built on top of it, and Polygon transactions are like 1/100th the price, right? If you guys haven't played with Polygon, it's worth trying out sometime. And one of the advantages is that you still get to use the security of layer ones. And I would argue that that's also probably the primary disadvantage to layer twos is that you're built on top of layer ones that aren't good enough to be layer ones, right? So I'm not a big fan of layer twos, to be honest. Like if you are seeing layer twos built on top of things, it typically means that that layer one that it's built on top of isn't good enough to use, period. And so that's kind of a hot take on Ethereum. Even though Ethereum 2.0 is meaningfully better, it still does not compare to something like Avalanche, which would never need a layer 2. Okay? So a layer 3 is a little bit. I don't really even believe in this idea of a layer 3 because it's not really the right way to think about it. Like we're not visualizing this correctly, as it's forcing us to visualize this like in a hierarchical manner when it's really like a horizontal scaling solution. Okay, so but it does tap into this concept of application specific blockchains. Okay. So that means it's a blockchain that's specific to an application. So say I have a video game, right? And the video game has so much load, so much activity. There are all these things going on, right? We were kind of talking about that the other day. With all that load and activity, it would not work. It would literally not function if it was performing on the same blockchain as say like Trader Joe, right? Or Sushi Swap. So it needs literally its own validators and everything, right? It needs its own dedicated blockchain in order to perform at the level it wants to. Okay. So let's talk about these horizontal scaling solutions that allow the Cosmos, Polkadots, and the Avalanches of the world to, to deploy alternative blockchains on top of itself. But really, it's a horizontal scaling solution. So you can see that the Avalanche network, when you visualize how its subnets work, it's essentially like there's this. You can think about it as like a organ, like a cell, right? And inside that cell, and like so, the layer zero is the cell, right? And inside the cell are all the subnets and all the chains, right? The C chain, X chain, all those things we're talking about. And the layer zero is the thing that is like that cell membrane that holds it all together, right? And then inside of it is kind of this neural network sort of thing, right? And if you see these types of clunkier designs, like these are okay, but it just can't compete with like the neural network design that exists with Avalanche, in my opinion. And so the other way to kind of see this is the subnet architecture each subnet is deployed on the P chain, okay? And the P chain is essentially used to communicate or is used to deploy new chains, right? And the X chain is designed for communicating between the P chain and the C chain. Okay? I know that's a lot. That's a more technical video, nerdier video than usual. But hey, this is good. I'm glad that we're getting to the bottom of these things, and you guys are leveling up your understanding of cryptocurrency in the world of blockchain and why what are these like all these buzzwords going around layer one, layer two, all these things, right? So I would honestly just of like anything that says it's a layer two, I would avoid it and go learn about things like Avalanche and Celestia as scaling solutions in blockchains, right? Because scaling solutions in blockchain very important, but it's even more important on how the scalability is being achieved. And if you're having to build on top of things like Ethereum or, like these things that are still very energy intensive relative to cost, right? Which is essentially how you should measure a blockchain is how efficient is it relative to the cost that it requires to run and the energy used to deploy it or the energy, like literally like I mean when I say energy, I mean like CO2 burn, things like that, right? So that's today's video. You guys are awesome. We're going to keep doing these obviously. I keep saying that every time at the end of these videos, but later.